Bismillahirrahmanirrahim. In today's video, we'll be discussing uh, example 8.2 and practice problem 8.2 from Mr. Hayt's book, and this is about RL circuit. So this circuit is an RL circuit, series RL circuit, and here we'll be using a term called I0 is equal to I. That means at t is equal to 0, this current will be named as I0. Now, there are two approaches that the book has used. One is called the direct approach, where the current IT, now remember in RL circuit, whenever we say IT, that means the current through the inductor. So IT is I0, this is I0, and e raised to the power minus R T over L. Actually, it is R over L multiplied by T. And then he has used another approach, and in that he is using A is equal to e raised to the power ST. So these are the two things we'll discuss as we go along. Now, what is S is the characteristics root, and this can be found from this value minus R over L. So S is minus R over L for RL circuit, and A is I0 is equal to I0. And again, now putting all these values here, you'll get the same answer. So whichever approach you like, you will follow, but we'll follow what the book has done. So let's see that. For the circuit and this, find the voltage level V at t is equal to 200 millisecond. Now this is the figure. So first of all, we'll take the circuit or consider the circuit for t less than 0. For t less than 0, that means this switch is closed. This is opening at t is equal to 0. So this switch is closed. And another phenomena that will occur is that the inductor will behave like a short circuit. We know that inductor value is present only for AC signal, not for DC signal. And so this DC is, when it passing through this, it will make the inductor behave like a short circuit. So from this circuit, now we can find the IL0 at t less than 0. It will be this voltage flowing through this path will be 24 divided by 10. So 2.4 ampere will be the IL0. Then at t greater than 0, in bracket I am writing transient period. Actually, when we move ahead, we'll notice that for t less than 0, the circuit is in steady state condition. For t greater than 0, this circuit is in transient period for some time. And then I call this as t greater than 0, where t is actually infinity. So in the simple RL circuit or RC circuit, we'll be only dealing with these two parts, not the t infinity part. Okay, now what will be this circuit at when transient? Then that means the inductor will not behave like a short circuit. The inductor behaves like a short circuit during steady state only. So this circuit we'll be using, and we can write KVL equation from here, minus V, and then 10 into IL, and then 5 into L didt or LDIdt. We also know that IL is now, this current is circulating around here. So in terms of V, we can write it as minus V over 40. Why minus? Because you see this current, we know that wherever the current touches first, that terminal should be positive. So according to the current, should be positive here, but according to the given value, this is negative. That is why we have to write negative here. So negative V divided by this resistance will give us IL. We'll put this value now in the first equation, and simplifying now, this you have to take the derivative. So only 1/40 will come. So 5 divided by 40 dv dt, and then these two we take V common. Okay, further simplifying, we get this voltage, this value, or this equation. This is the first order differential equation, and d by dt is written as S to simplify this whole thing. So it will be SV plus 10V. We take V common, so it will be S plus 10. Now this is called the characteristics equation. So from characteristics equation, we can find S to be minus 10. So now we'll put into the general solution that we have assumed A e raised to the power minus st. So for S, we'll put minus 10. It will become A is equal to V naught e raised to the power minus t. I think there's a mistake here. It should be only st. A e raised to the power st. So that is why it will be negative. Okay, now up to this point, we could have done it directly also. We know that the Vt is A constant e raised to the power minus R over Lt, or it can be written in this way as well. From the circuit, R is 440 plus 10, 50. So 50T divided by L is 5. So we can get this directly also. Anyway, now we need to find V0. Now to find V0, we are again using this IL is V minus V over 40 relation. And from here, IL can also be written in terms of T. So ILT is equal to minus VT over 40. And from here, we can write VT is equal to minus 40 into ILT. Now at t is equal to 0, this will be V0 and this will be IL0. And IL0 we had found already to be 2.4. So we'll plug in that value. That means V0 is minus 96 volt. So we'll plug in this value in the equation given here. So this is our answer. Vt is minus 96 e raised to the power minus 10t. Now this is the general equation. Now the question has said that for t is equal to 200 millisecond. So simply we have to put t is equal to 200 millisecond to get the answer in millisecond. So we have got this voltage in terms of t. Now at t is equal to 200 milliseconds, that is 0.2 seconds. If we just put for t is equal to 0.2, solving we get the answer minus 12.99 volt. This is the first question. Then we'll do the practice problem. Now determine the inductor voltage for the circuit, and the answer is also given. So we'll follow the simpler technique. That is, we assume that the output or the solution or the current is I0 e raised to the power minus RT over L. And for t less than 0, as we had discussed earlier, the inductor will become short circuit, the switch will be closed. So from this path, we can calculate the IL0. So IL0 or I0 is 10 volt divided by 4 ohm, so 2.5 ampere. And for t greater than 0, the transient period, we will get this equation, this relation. And so R from here is 10, 6 plus 4, and L is 5 Henry. So just plug in into the equation here. It will be I0, we have already calculated 2.5, and e raised to the power minus R is 10 and L is 5. So it will be 2.5 e raised to the power minus 2t. Now this is the current. Now we have to find voltage. So voltage is L di dt, and L is 5, and then di of this. So differentiating, and further, so we'll get the answer minus 25 e raised to the power minus 2t volt. So I hope you have been able to follow this. Please let me know through your comments. Thank you. And this is the answer given in the book also.